Let's continue our exhausting process. So a week or maybe even 2 weeks ago, I was trying to solve this problem and I almost did it, but some formulae are wrong. Yeah, so let's look into it. So we have kinda correct answers, but the problem is that, for example, this formula, the function is not uniform. So let's, for example, try to double everything. Yeah, so 2, 2, 2, 2, 2, 2, 2, 2. So if I do it, all answers should double. However, we clearly see that while this number doubles and this number doubles, this one did not double. So we have a problem with this test. And we need to look into it. Did I choose it right? Yes. So this test is wrong. This test gives a negative result. To understand the issue, it seems like we need to... Well, we just need somehow to understand why it is negative. Yeah, because... So what is this? So this is like two perpendicular segments. Yeah, these are two perpendicular segments. We need to understand which of these formulae is not uniform. So after doubling all numbers, it does not result in doubling the answer. And I believe we can do it. Yeah, so I think we need to remember first. We need to remember what do we need to remember? We need to remember what are the parameters. So what does this function do? This function find integral, I believe, works with the following integral. We are given an angle alpha, and this segment is equal to A and this is equal to B. And we need to find the expected distance between such 2 points. I think this is the thing. Of course, if we double everything, then the answer also should double. However, it became negative. Okay, let's also what I want to do... What's wrong with my camera? Yeah. Let's also look at something like with this. And I see. I only can use integers. Okay, never mind. Okay, this was uniform, this was uniform, this was uniform. Okay, this is all of the dimensionality 0, dimension 0. Okay, B is clearly something cubic. B is clearly something cubic. Yes? Cubic. Okay, let's look into it. Yeah, it is cubic. B is cubic. This is power 0. So this is like constant. This is constant. This is cubic. And now we have all these calc C1, C2, and C3. Okay, for example, C1. Since I add something squared and 1, it seems like x is of dimension 0. Okay, Kc is cubic, so the total thing is cubic. So x should be of 0 dimension, and the answer is cubic. Then I put here x cup and xc up and xc down, which are both 0 power. So indeed C1 is cubic. In the same way, this is cubic. Yes, and C2 is also cubic and C is cubic. Okay, the answer is C plus D minus B. We already have it that... Okay, let's for a moment look here. Yes, so L1 and L2 are definitely linear. So this is square, this is cubic, this should be cubic. So the answer should be linear, and it indeed should be linear. So I expect all numbers A, B, C, D, and B to be cubic. I already have it that C is cubic. So let's check D and B. Okay, start with D. So this is cubic, of course. This... Okay, this is strange. Yeah, because I have a logarithm of A. Why do I have it? I cannot have a logarithm of A. I cannot have logarithm of A. Because A is a distance. I cannot take logarithm of any distance. So this is not correct. Let's see how it happened. Okay, this is not easy to understand how it happened. It's not easy. So it is somehow, it's called D, yeah? So I have D. Oh, D is here. Yes. So somehow during calculation of D, I got here it is. So how did it happen? Ah, because it is log of sine of alpha. What? No, I don't understand. Log x is strange, since we have x from 0 to a. No, I don't get it. And this happens? Okay. Okay, we need to look here and we need to understand if it makes sense. And if it does... Oh my god, again. Okay, let's look here. Let's look here. We need to understand why it doesn't make sense, because it does not make sense. Yeah? Okay. Yes, here we definitely have that I have logarithm of x, and it is linear, which is bad. But this happened because I also have a logarithm here, which is also linear. Okay. Let's see. Ah, I have calculated the orange part, which is fine. I calculated the green part, which is not very fine. Okay, in the end, it should be something like log of A over B, or something like that. It cannot be just log A, because it is a log of a distance, and I cannot have a log of a distance. So I need to integrate this logarithm. And the integration of this logarithm is not straightforward. Oh, it's hard to upsolve problem which you have totally forgotten. So, what do I expect to see? I expect to see... Yes, so here I have minus alpha cubed sine squared alpha over 6 times logarithm... no, here. Minus sine squared alpha a cubed over 18. Oh, okay. Over 6 times logarithm of alpha. So I expect something to be added. I expect a cubed sine square alpha logarithm of some distance over 6 and it should be added. In that case, it is fine. So now, for now, this is the only part, the only addend which is not uniform. So this is a non-uniform addend, and I expect it to be added somewhere below. Most obviously, it could be logarithm of b, for example. Okay, let's go. So I said that this is c, and having that c, so c is what? C is some distance. Okay, now I'm trying to integrate something dc, and here I have a logarithm of c. And then something really scary happens. What is the variable of integration? What am I integrating? What is it? What is the integration variable? R? So R is my variable. Why didn't I write what R is? What is R? This is D1. So D1 must contain logarithm of distance times alpha squared times alpha cubed over 6. Okay? Okay, let's see how it happens. So this is logarithm of distance. It is multiplied by something over 2, b squared, a squared, a cubed alpha squared, sine alpha squared. So here we have sine alpha squared. So I also expect somewhere here to be a cubed. But where do I expect it? And why did C turn into R? How did R appear? Where is R defined? This is really strange of me to not define what R is. Maybe this happened somewhere else? No, it did not. It didn't happen. Okay, let's look closer. Let's look closer. I have 1 over 2 sine squared alpha. Here we have this thing times cosine of C, times logarithm of C times this linear function. Not linear, but strange function. Is it under the logarithm or not? It is not under the logarithm. Dx is this times, what's wrong with you? This times dc. So this, what I wrote here, this is this times dc. But I really don't understand what happened afterwards. Maybe I changed my perspective and I tried to take this logarithm some other way. Yeah, maybe yes. So let's go back to this formulation. Yeah? Sorry, I'm not fresh. Okay, let's take this thing, copy, no, copy, no, pull down. Let's put it here. Let's make it for now smaller. Okay, so I am trying to take this integral. I made some standard variable change. So let's remember which variable change I did. So what can turn 0 into minus cotangent alpha? Minus cotangent alpha. So how did it happen? I don't remember actually. Ah, yeah, it is standard. However, it happened. I don't know, when did it happen? It happened here. Yeah, it happened here. Let's try and fix something, I think. Because it's really not good. It's not good. And what is B prime? What was happening in my head while I was writing that? Okay, maybe we need to select this and can I only can move it? What? Can I move it down? What is wrong with you? It seems like maybe we will need to take this integral again. While I don't want to do it, I will have to do it. Okay, let's move it to the bottom of our page. Oh no. Okay, I have moved it to the bottom of my page. Now I can select it. I can select this, move it here, and let's continue our hopeless calculations. So as I was saying, it seems like we need to... What was I saying? First of all, as usual, we want to... So let's forget about this one. We want... Okay, this integral is called d1. So d1 is what I want to calculate. So we were saying that... I need to change my variable so that this square root does not contain linear term. In order to do that, I need to say that now y is what? Is x minus cosine alpha. This means that x is y plus cosine alpha. No, this is not good because plus b minus b cosine alpha, I think. Yeah? Okay, let's see. So since I now have variable y, it is from minus b cosine alpha to... and I can immediately divide by b, I think. Yeah? Can I divide by b immediately? I should be able to do it. Yes. So let's take x over b minus cosine alpha. And so x is oyb y plus cosine alpha b. Well, in this case I can also immediately divide by sine alpha. Okay, let's immediately say that t... Yeah, I'm redoing this because I already did these steps, so let's assume that I am capable of doing them. So x over b sine alpha minus cotangent alpha is t. So x is tb sine alpha, tb sine alpha plus b cosine alpha. So t is now from minus cotangent alpha to a over b sine alpha minus cotangent alpha. So far so good. X squared is b squared times something. It's b squared times sine squared alpha times what? So now we have here t sine alpha plus cosine alpha squared. All of this is taken over 2. Then logarithm of b minus x cosine alpha, which is minus... Okay, let's try it. Minus tb cosine alpha sine alpha plus minus b cosine alpha squared plus square root of plus b and times some square root. So first of all 1 minus 2 cosine alpha t sine alpha plus cosine alpha and plus x squared, which is again t squared sine squared alpha plus 2t sine alpha cosine alpha plus cosine squared alpha. Let's go. Okay, here we have b squared sine squared alpha t sine alpha plus cosine alpha squared over 2. Okay, after that we have times logarithm of what? So here we have b minus b cosine squared alpha. It is b sine squared alpha. B sine squared alpha minus tb cosine alpha sine alpha. Let's look at the square root. Okay, first of all, this is minus 2 cosine alpha squared, and this is plus cosine alpha squared. So in total, this is min cosine squared alpha. But since we have 1, we have sine squared alpha. And this resulted from these three addends. What else do we have? We also have 2t sine alpha cos alpha, and it is annihilating with this one. And also we have t squared sine squared alpha. Yes. Okay, after all this, we can remove b sine alpha from the logarithm. Okay, let's continue. Cotangent alpha, ab sine alpha minus cotangent alpha. Okay, for now let's let it be. So b squared sine squared alpha, t sine alpha plus cosine alpha squared over 2 times logarithm of b sine alpha plus some other logarithm. Let's see. So this is sine alpha minus t cosine alpha. Also, it should be b times all of this. And if we remove b and sine alpha, it becomes simply square root of 1 plus t squared. Okay. Okay. Okay, what happened after that? After that, I said that this is sum of the following integrals. Integral from minus cotangent alpha to a over b sine alpha minus cotangent alpha of a k t to the power of k times this thing, logarithm of b sine alpha plus logarithm of sine alpha minus t cosine alpha plus square root of 1 plus t squared. Okay, and I said that we only have k equals 0, 1, and 2, so we need to take these three integrals. Okay, let's try again, because this is what I did exactly. This is exactly what I did. So, let's try again. So let's take integral of t to the power 0 times logarithm of b times sine alpha. Okay, I can even use extended keyboard to use my preferred alpha plus logarithm of sine alpha minus t cosine alpha plus square root of 1 plus t t squared dt. Okay. No, I want to stop. Can I stop? Control F5, I think. No? How do I stop? Ah, Shift F5. Ah, I can write from 0 to 1 or not. Can I? Ah, I need to write comma. And number, point, number. Ah, t equals. Okay, if it doesn't say the answer, then I am quite unable to do anything. Any usage of computer is beyond my limits. Comma, variable equals thing, dot, thing. What is it thinking about? Why so long? Maybe I can write 1, 2. Do I need to do it myself? Dude. Okay, what did I do? Ah, I subtract, I understand. Okay, let's assume that it is without other limits. Okay, let's try again. So what do I have in... What? 0.5 times b cubed? Why? Why? Why b cubed? Sorry, but what? Here I have... I need to multiply... Okay. Okay, sorry. I was wrong. All this time I was wrong because when I write t and x, I also need to write dx, and dx is b sine alpha dt. And actually, when I do this, I get here b cubed, and here b cubed, and here b cubed, and here b cubed, here b cubed, and here b cubed. So actually, so I just write like this, but then I need to add a coefficient. And we need to check it. Okay, first of all, let's check upper and lower limits. So upper and lower limits I chosen as xd up and xd down. Xd up and xd down are same as for c. And for c we have xc up is a minus b cosine alpha divided by b sine alpha. A minus b cosine alpha divided by b sine alpha. And lower is simply minus cosine alpha over sine alpha. Yes. Yes. Our assumption is that it is correct. Okay, let's substitute. Let's find the coefficients. So for t to the power 0 we get b cubed sine to the 5th power over 2. B cubed sine. Actually it says sine to the 3rd power and cosine to the 2nd power. Why? No. It should not be like this. It should be sine to the 5th power. Right? But for some reason it says that in the 2nd. Okay, yes. B cubed sine to the 5th power times 1/2. Then in the middle we have b cubed sine to the 4th power cosine. Okay, so we need to integrate this thing. We need to integrate this thing. And in order to do that, what we need what do we need? We need to integrate several things. Several. Okay, let's look into this formula again. So I expect here to be exactly this thing. So t times logarithm of b sine alpha. So also we have a big log, which is logarithm of sine alpha plus square root of t squared plus 1. Yes. We have log BSA plus t times log BSA plus big log minus 1 times cotangent alpha times big log plus cosecant plus cosecant times this inverse hyperbolic sine function. Okay, maybe it's fine. What about t to the first power? T to the first power is equal to minus 1/8 of sine squared alpha times some huge parenthesis. Minus 2t squared log BSA plus cosine of 2 alpha times t squared times two. Actually, let's replace with x. Two log BSA plus 2 big log minus 1 close plus 2 big log. What? This time it is minus sine alpha minus square root of x squared plus 1. No, this is bad. This is not good. What is this transformation? Why is it negative logarithm? So if we're talking about logarithm of minus 1, it is something imaginary. Yeah, and it says assuming a complex valued logarithm. However, it shouldn't require a complex valued logarithm. It shouldn't require it. That is strange. Maybe we need to just assume that it's actually fine. Maybe we just need to assume that it is actually fine. Okay, 2 log BSA plus 2 big log minus 1 plus 2 times big log minus 4 square root of x squared plus 1 sine alpha minus 2x squared big log plus 2 big log plus x squared minus 2x sine 2 alpha plus 4 cosine alpha. Okay. Let's look at this one this time. Adventure. Adventure. Actually, crappy adventure, if you ask me. Minus 1/72 of cosecant function times minus... Okay, what do we see here? Why does it start with minus 18x cubed? So for some reason, sometimes it just changes. It just changes it for its form. Okay, let's try it. Let's try write the correct form, like in the Wolfram. First of all, minus 18 x cubed sine alpha logarithm BSC. Plus 6x cubed sine alpha. We have it here. Minus 2 x cubed sine 3 alpha. Plus 12 square root of x squared plus 1 sine 2 alpha. Plus 3x squared cos 3 alpha. Plus 6 square root of x squared plus 1 x cosine 2 alpha. Minus 6 no, not correct. No, minus 6 here. Plus 6 x square root of x squared plus 1 x cosine 2 alpha. Minus 6 so here it changes. For some reason it is minus 6. It doesn't change. Minus 6 cosine 3 alpha logarithm of okay, big log actually, just big log. Minus 6 cosine 3 alpha big log. Minus 3 cosine alpha times 6 big log plus x squared. Minus 6x squared plus 1. Okay, where is it? What? Where did it disappear? I don't have it, yeah? Minus 6. Here it is. I have it. Minus 6 x squared plus 1 square root x. Okay. Here it is. Maybe I got it. Yeah, so actually, after that I have minus 18 x cubed sine alpha big log. And I wrote it, but actually I didn't write the correct. Also, it should be log BSA. So I need to add two logs. I need to add log BSA plus big log. A sneaky error. Then plus 6x cubed sine 3 alpha big log plus 6x sine alpha plus 6x sine 3 alpha minus 6 3 cosine 2 alpha plus 1 times arc sine x and in the end no this. Nothing here. What? Okay, let's try it like this. Maybe. I think it becomes that everything is not correct. Just everything is not correct. Did it become it? No, it did not. Actually, it is quite decent. Yeah, so it's really double this thing. Let's admit it. It's funny because actually the probability that it gets accepted is still low. It is still low, but maybe something good happens. No, it did not. Ah, we have a test. Well, it is it is bad that we look at the test. But let's look at it. Let's look at the test. So 0, 1, 0, 0. Zero minus 1, 0, 2. This is actually a shame that I didn't solve this problem when two segments lie on the same line. 0 minus 1, 0, 2. So I failed this test. I really failed this test. Okay, let's solve it naively. Okay, so what is usually the answer? The answer is usually, first of all, let's take the inner integral from 0 to 1. Then let's take the outer integral. Then we'll take the inner integral as the sum of two integrals from minus 1 to x, and here I have x minus y. The plus integral from x to 2, and here I have y minus x. Let's calculate. So this thing is xy minus xy squared over 2 minus 1 to x plus y squared over 2 minus xy from x to 2 equals from 0 to 1 so we substitute it to y, so x squared minus x squared over 2 over 2 plus x plus 1 half minus 1 half plus 1 half, then plus 2 minus 2x minus x squared over 2 plus x squared. Well, now we have from 0 to 1. What do you need? So this annihilates. And I'm using the word annihilates correctly because there are several things that bump into each other and destroy each other. Okay, here we have also plus x squared, which is preserved, minus x squared minus x, which is preserved, and plus 5 seconds dx. This is x cubed over 3 minus x squared over 2 plus 5 seconds x from 0 to 1, which is simply 1/3 minus 1/2 plus 5 seconds, which is equal to, let's multiply it by, okay, this is 2 plus 1/3, which is 2.333. No, this is definitely not fine. What? This is definitely incorrect. Why is it so big? Why am I unable to take an easy integral? Like trivial integral. It's not funny. It's not funny. I should be able to take such integrals. I need to divide it by 3. I need to divide by 3 because the product of the lengths of these two segments is 3. So when I divide it by 3, I get 0.7777, and this is already correct. However, instead of 7/9, I gave, no, it is it same? Yes, it's 7/9, but I gave 5/6. Why did I do that? I did that because I'm unable to take the easiest integrals on Earth. Yes? Let's see what I did. What did I do? This is a parallel integral. So how do we calculate a parallel integral? Let's go back to this parallel integral. But here it is. Here is my parallel integral. The problem is when h equals 0, maybe it doesn't work. Can it be? Can it be that it doesn't work when h is 0? Do I really need to write a function, especially for two segments on one line? Yes, I think it does. It cannot just work. It cannot work. What? What is find linear parallel integral? What is this? Ah, no, I have a formula, but it is incorrect, it seems. Yeah, I have sometimes, I have such an integral. Oh. So I have h equals 0. So it gives 5/6. What? It is not giving me 5/6. Ah, it is giving me 5/6. And I think it gives it to me right away. So stack, find linear parallel integral. Answer. Hmm. Okay, let's see what it says. It says that I need to find an integral from a number to a number of linear function times this function. Yeah, and this is called linear integral. Yes? This is called linear integral. AB KLH. AB ABKLH. So I have a problem. With this integral when h equals 0. It becomes from a to b kx plus l times modulus of x dx. But I have a 0 here, so I always know my sign. Yeah, so let's call it u. I know that it is simply integral from a to b of kx plus l ux, which is k, which is u times k like this, u times b minus a k a plus b over 2 plus l k What? I'm really handicapped. I don't know. Why didn't I manage to calculate this integral? Ah, because it is x. Sorry. Again, I'm so stupid for some reason. Integral from a to b, kx squared plus lx equals kx cubed minus over 3 minus lx squared over 2 from a to b, which is k b cubed minus a cubed over 3 minus lb squared minus a squared over 2, which is equal to b minus a times la plus b over 2, no, minus u and plus, actually, why am I writing minus? U by b minus a, la plus b over 2 plus k plus b squared over 3. Okay, so u b minus a, la plus b over 2 plus k a squared plus ab plus b squared over 3. What did it fail to do? Can somebody explain to me? So what it is saying to me? It is saying that since we have this segment and this segment, there are several possible vectors which range from -2 to 2. Yes, so let's start with -2. What does it say? It says that we are integrating from -2 to -0.5 function x plus 2 times absolute value of x, which is minus x. Mm-hmm. Now, intuitively, it says the following. The linear function is how much do we see such a length of a segment. And modulus of x just says that we have this length of the segment. Yeah, for instance, if length of segment is -x, yeah, it says how much do we see it. We see it x plus 2. For example, if it is -0.5, then we see it 1.5 times. However, it is not the case, because the length -0.5 we cannot see so much because it ends here. So this means that I failed to make a proper division points here. I failed to make proper division points here. So how did I choose them? Not very cleverly. So let's do something. Let's look at the picture. In the picture, here is the picture. So what are all possible vectors? So we start with what? C minus A. This one, C minus A. Well, it makes sense. C minus A is indeed something valuable. And we end with B plus C. Yes, we end with B plus C. So this is the most extreme vectors. So when does something change? Actually, this is not the correct division points of changing something. The correct division points are, okay, 0 is fine. Also, this vector, I think. So just C and C plus B minus A. Yeah, so we just need to not divide. And 0. Okay, maybe this should be correct. Okay, now it's again better. It is better. It's actually sad that taking this integral is so nasty. But maybe our suffering is going to end. Still second test. Third numbers differ. Why didn't I see that? It says 0. Well, it's strange to debug a solution using actual tests, but whatever. What is it? Actually, these are two vectors. Let's look at them. Faster. Let's look at them. So, they are almost parallel. Yeah, it's understandable. They are almost parallel. Can you just disappear? What's wrong with you? Okay, they shouldn't be, even if they're almost parallel, the answer shouldn't be 0. Okay, let's look at something. First of all, I just want my own test. I don't want it. So let's take 0, 1000, 0, 0, 0, 1000 and 0, 0, 0, 1000. So after that, it is just 1000 over 3. But if we replace it 0 by 1, it somehow changes. But what if we write that like this? Okay, this is strange. This is strange. All I did here it wasn't much. It wasn't much. Okay, what if I write like this? Okay, in this formulation it makes sense. It's a bit smaller, but when I do this, I just moved the segment a little bit. It should add at most 1, but it added almost 100. Also, all these integrals are just huge. No, they shouldn't be that big. Why are you so big? So, whatever you do, you always multiply by sine cube alpha. Always. Everything is multiplied by sine cube alpha. Why is it still big? Ah, it should be big. Yeah, it should be big because it should be divided by 1 million. Okay, if we divide it by 1 million, they are almost adequate. Okay, what I think is I think that these two integrals should be almost the same. They should be almost the same. What is the difference between int1 and int2? It is negligible. Yeah, here we have 1000 and 2000, and here we have 2000 and 1000. Okay, what happens if we swap them? What happens if we write L1 and E2? Does it change a lot? And immediately it is tiny. Okay, this definitely does not make sense. Almost nothing changed. So we want our integral to not change when we swap K2 and L1. Do I ask for a lot of privilege? I dare say that not. Oh my god. But how to debug it? Like how to debug it? Well, it seems that I forgot to multiply by some sign somewhere. Do I really want to recheck all my solution everywhere, all possible places of doing something incorrectly? It's not something that you'd like to do, is it? I have more interesting question. How is it 0? How is it possible that it is 0? Okay, maybe it is possible, but questionable. Are you kidding me? It is something to the power 28? Okay, this should be easily debuggable because it cannot be so big. And since it cannot be so big, it means that somewhere there is an error. And if there is an error somewhere, it can be so big because I have such a big number. I have 2.8 billion here and 2.8 billion here. And so it is like its product is something like 5.7 E18, and if we cube it, it becomes E54. Well, maybe we need long double. Maybe we need long double to perform this calculation. Okay, I don't have long double on my PC. Are these numbers really that big? Okay, they are quite huge. I'm not sure that you're... Oh my god. So is it true that I simply don't have enough precision? Maybe I don't have enough precision. Okay, now it at least gives non-zero number. It's still totally incorrect, but it is non-zero. Okay, maybe we will be able to fix it if we fix the reason why this answer is totally incorrect. Okay, let's look. Let's look. So when we have 0, 1000, 0, 1000, or 0, 1000, 0, 2000. Okay, when we do that, we get 1/3 and 2/3. Should it be 2/3 actually? Yes, it should be 2/3. Okay, this is understandable. Totally understandable. Let's look at the other test. When we have I want to look at this test. So I expect integral 0 to be about 1000. About 1/3. But times million, so 333,000. No, times. I see. Times million cubed. Okay. In this case, it's kind of fine. What about int1 and int2? It should be double because one of the segment is doubled, and it should be also double because the answer is double. So it should be 1,333,000,000. I want to be see instead. We see a bit more. Okay, this is fine. This is fine, but this is much bigger than you need to have. So answer, well, it's strange. It's strange. How is it possible that answer is nearly correct when k1 and k2 are equal? It is nearly correct. Let's put it simpler. Let's put it simpler. Let's put it simpler in the case when there are two perpendicular segments. So I have segment 0, 0, 5, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1. And vice versa. Vice versa, like this. And the answers are clearly different. They are different because everything is not good. Everything is really not good. I might have correct answer when they are equal. but otherwise it is not. Well, it is a disaster, if you ask me. And what am I supposed to do? Okay, we know that this function is symmetric in A and B, but what am I supposed to do? How am I supposed to fix it? How am I supposed to know what is wrong? Again, so the problem is usually when A, let's put it that way. We have a problem when what? When A is less than B. Yeah, when A is less than B, we have a problem. A is less than B, then there is a problem. When A is less than B, we have a problem. Okay, one easy fix would be to swap them if A is less than B. We can employ that easily. If A is less than B, return find the integral of B A sine alpha cosine alpha. And what do we see? After that, everything is correct. All our problems are no, not all our problems are solved. Moreover, this becomes a disaster. What? Okay, I understand this. And but this becomes something not very good. Yeah, we did not solve any of our problems. What can you do? What can you do? Maybe this means that we need to massively simplify our formula, like really massively. Okay, I don't believe that. Okay, in this case, for now, let's remove it. In this case, it is already really bad. So this difference of more than 1% clearly indicates that we are doing something wrong. Okay, I have an idea. Maybe we need a more clever approach to our integration process. Maybe we need it. I didn't want to say that, but maybe it is needed to change something in the process. So if there is something, what is it? What is it if there is something? Okay, I can't say what problem there is. There is the following problem. If we have two almost parallel lines, then actually we get this figure, and it can be rather small compared to this thing. And it can result in precision issues, which we are already facing. So instead of that, maybe we need to look at some more precise method. What a more precise method would be? The more precise method would be to take two segments. What's wrong with you? To take two segments and integrate over the direction. So let's the first integral be from 0 to 2 pi. And we will consider the direction of our segment. Okay, first of all, if two segments are parallel, then everything works. We can stick to that. It's fine. The problem is when they are not parallel. Or even better, when they are almost parallel. Okay, let's integrate over all possible directions of our segment. There are 2 pi directions. For each direction, it is limited by... First of all, we still have an angle. Yeah, we still have some angle in which there are these segments. But also, we have two fixed points, either here or here or somewhere else. Yeah, so for example, for this direction we have from here to here, so both points are here. Okay, so we integrate over all possible angles. After that, we integrate over all possible positions. There is a problem because equiprobable angle is not same as equiprobable points on two segments. And we will need to somehow fix it. Well, the fix should not be very hard. The fix should not be very hard. Let's take two segments. Let's take 2 points of some direction. And let's take a small we can draw it like this, for example. First of all, we can assume that two segments do not intersect, because if they intersect, we can divide them into 4 segments which do not intersect. Okay, after that, we can assume that we just take a line, and the line goes from some position to some position. And maybe we even integrate from 0 to pi. Okay, so let's take some horizontal axis, and let's say that this angle is alpha and this angle is beta. Yeah, and we take some segment with some normal angle gamma. What is the probability of such line? We need to fix the probability. So assume that we take a unit segment here, a unit segment. Then this unit segment is projected here, and we get something like cosine beta minus gamma. And here we get times cosine beta minus alpha. So this is the density. Okay. So we integrate over all possible gammas. We always take cosine beta minus gamma, alpha minus gamma, cosine alpha minus gamma times the difference of two projections. So what do we have here? Here we have some two fixed points, and there is some vector between these 2 points, v. So here we multiply it by v. Not by v, let me think. By, how is it said? It is said that we need to take a unit. So as usual, we need to take the argument of this vector, which will be delta. And here we multiply by cosine delta minus gamma. multiply by modulus of v. So actually, it's not very hard. We have this expression, product of 3 cosines, product of 3 cosines and a number. This is not bad. This is actually okay. Yeah, this is actually okay. So also we may assume that all these moduli are removed and we just take the area where they are all positive, the cosines. The question is how to integrate all of this. How to integrate all of this? Actually, it seems like this is just some polynomial of sine gamma and cosine gamma. It is a cubic polynomial. So we need to integrate all possible cubic polynomials of gamma, of like sine gamma, cosine gamma. This is not good. But we've been in worse places. Okay, let's try. Let's try. It's worth a try. Worth a try. Actually, it's much better than everything that was before, because it's not a very hard integral. Okay, let's start. Let's start. Well, I don't want to calculate it, but we will. We will. So, first of all, sine cube x. How to calculate such an integral? Well, I could use Wolfram here, but I just need to do it in principle. I just principally have to do it the fair way. I know what I want to do. Let's remember some formulae. We know that if we have a cosine of alpha times cosine beta, what is it? I believe it is cosine alpha minus beta plus cosine alpha plus beta over 2. Let's apply this to this product. So we have cosine of beta minus gamma times cosine alpha minus gamma, and this is equal to cosine beta minus alpha plus cosine alpha plus beta minus 2 gamma over 2. Okay, then we multiply it by another cosine. This is something that we can do. Okay, first of all, I don't want to multiply some constant cosine by some non-constant cosine. So my first addend is simply cosine delta minus gamma times cosine beta minus alpha over 2. Okay, now let's combine these two cosines. So first of all, it's cosine of difference alpha plus beta minus delta minus gamma plus cosine of sum alpha plus beta plus delta minus 3 gamma, and finally over 4. Okay. Okay. Yes. Let's go on. Now we need to integrate it. Okay, maybe I would like to combine this thing, because it might look nice. Yes, it might look nice. Okay, let's do it. Let's do it. Do I want to do it? It will get us a symmetric form, which I kinda like. On the other hand, there are reasons not to do it. Okay, let's avoid complications. So now we need to integrate it d gamma. D what? D gamma? D what? Is gamma the angle? Yes, gamma is delta. Gamma is the angle, yes. So let's integrate by gamma. And we get minus sine delta minus gamma cosine beta minus alpha over 2. Or, to put it simple, gamma minus delta. Plus cosine gamma plus gamma minus alpha plus beta minus delta over, again, 2 over 4. And here it's a bit more tricky, because now it is cosine of 3 gamma minus alpha plus beta plus gamma. Okay, it's sine, of course, sine. And this time over 12, because you know why. Because we have 3 under the sine. And since we have it, okay, actually this is very simple. So I just need to multiply modulus of some vector v by this nice thing. Okay, so this integral totally okay. The problem begins when we want to represent our big integral as sum of such integrals. So we have two vectors. Let's assume for now that they don't intersect, and moreover their intersection point lies somewhere here. Just for a moment. Let's assume that. In this case, actually all possible vector directions are between these 2 points. And there are also 2 such directions. This one and this one. Let's continue these 2 lines. And this means that there are like four types of directions. Yeah, there are 4 types of directions. First of all such directions, like this, they are all meaningless. They cannot intersect both of our segments, so we ignore them. The second type is this one. So all these directions, they intersect from this point to this point. Okay, the third type is these directions. Let me draw a more nice picture. Okay, what about these directions? For example, like this. It is between these 2 points. Then this angle, let me choose one more color. This angle is between this line and this line. And this is between these 2 points. Finally, and that's it. There are 4 types of angles. So if 2 segments do not have an intersection point between them, there are 4 types of angles. And this is simply the integral, nothing more, just the integral, just calculate the integral. There are tricky cases, however, for example, this one. If we have a segment, and on top of that there is another segment, maybe we don't want to work with, well, okay, the easiest thing that we don't like is this pair of segments, because any direction actually can intersect both of these segments. For example, this one, this one, this one, this one, this one, this one, and so on. All directions intersect them, and we don't want to consider all of them. So instead of that, we will take the intersection point and consider that such two segments. So now let's assume that we just have two segments that might contain their intersection point and start in it. What is true in this case? In this case, actually, these angles do not exist. Yeah, so okay, so what do we need to do? So I want to represent my segments. Okay, I will return in a second. Okay. Sorry. I have some snacks. Okay, so step one. Step one is to take two segments, and if one or two of them contains the intersection point, then we eliminate the intersection point. Actually, let's do the following. Let's take an epsilon here and remove these parts. Just remove all these parts. They should be like excellent. So now we may assume that we have two segments like this. They don't intersect at all. So let's call them AB. Actually, first of all, this one AB, and then this one CD. Then there are 4 types of angles, from AB to CD. Actually, from CB to AD. These all are easier. Then we need to rotate until we either hit this or this. And this can be easily checked with a vector product. Okay, it seems like maybe I have come up with a method which won't even need Wolfram at all. So let me close Wolfram. I will not use it. Let us also remove all this mess. Okay, actually, parallel integral is not that bad. Parallel integral is really not that bad. Let's keep it. Okay, so let's find dance G and H. Actually, I don't want... Yeah, so we can do all of this, but here we need to fix our solution. We'll do something new. So what do we need to do here? Here we need to intersect our 2 segments. And if they do intersect, sorry, it seems like I will now work without camera because it feels not very good. So we need to divide our integral into 4 integrals. So that should be quite easy. Okay, so we take two segments, they are not parallel, so we intersect them. We get some point. Then we need to check if this point lies on each of these segments. This is quite straightforward to do. Let's consider this tricky case. So in this case, between here and here, we have nothing. Then between here and here, we have some intersection. Okay. Let's try and calculate the intersection of two segments. Pascal. We have a Pascal here. Okay, so PDD intersection. How do we intersect two segments? Usually it is done as follows. So we have AB and we have CD. Then we ask, what is such number x and y numbers that x here is same as y here. So we say that a plus x b minus a is c plus y d minus c. After that, let's take a normal vector to a minus b. For example, normal vector which is equal to rotation 90 degree of b minus a. And multiply by n. So we see here that an plus 0, yeah, because this is perpendicular to n, is cn plus y d minus cn. And this allows us to calculate that y is an minus cn over d minus cn. And after that, we can actually say that vector times rotation of by 90 degrees of some other vector here is simply w times v. So this is the outer product. No, not outer, how it's called. Is it called vector product? I forgot. Yeah, it's called maybe outer product or vector product. So we clearly have b minus a times a minus c over b minus a times d minus c. And we also can multiply by m, which is rotation of d minus c. And instead we can get ma plus x times mb minus a equals mc. And so x equals d minus c times c minus a over d minus c times b minus a. Okay, after we've done it, let's write this formula. Yes, so we can return. This is not the end. Unfortunately, it is not the end, because not only do we need to calculate x and y, we also need to calculate the point. So the point becomes quite simply a plus b minus a times x. Yes, so we need to take a plus b minus a times this strange formula. So first of all, we need to multiply a vector by a number. Also, we need float something divided by something. Let's also denote everything by A, B, C, and D. Okay, we have done everything that we needed, which is nice. So let's calculate. So in the end, actually, so we will have float integral equals 0, and we will return integral divided by L1 times L2. Let's make a structure float segment. Okay, now let's make an intersection point. Which is intersect G and H. So if intersection point. Also, let's make two vectors. Of G's and H's. And if the distance between intersection point and GA plus the same distance for GB minus the distance between GA and GB, which is simply L1. And if this is less than 1e minus 10, this means that probably we need to subdivide our segment into two. It's actually the same for H. Let's make the intersection. Or not intersection, but distance. Okay. Now we are capable of calculating the distance. So now we need to say that for float segment G prime from GS and for float segment H prime from HS, integral plus equals find the integral of g prime and h prime. Let's check that it at least compiles. This actually compiles, which is nice. Now we need to implement our function. Actually, let's always direct our segments from intersection point to other point. So if distance between intersection point and J is less than distance between intersection point and GB, then we firstly need to take J and then GB. Else, first GB, then J. And same here. Let's find the integral. So now we have two segments which are oriented from the intersection point to other point, and they are not parallel. Let's swap them so that, yeah, let's swap them. I want them to be in the following order. Firstly this, and then this. And this is quite easier. So if G B minus J percent HP minus HA is less than 0, we need to swap G and H. Well, now they are in correct order. So let's call this AB and this CD. Then from CB to AD, everything is straightforward. It is simply this area. Then we need to either go from this direction to this direction, or from this direction to this direction. How do we choose? And either it is this is always AD, but the question is where it ends. To understand where it ends, we simply need to take these two segments and take a vector product of them. Okay, so let's take the vector product. If GB minus HB minus GB percent H A minus J is greater than 0. Okay, let's assume that it is greater than 0. Then it looks like this. So the intersection point is somewhere here. Also, there is a case when it is 0. In this case, we also want to take the right one. So let's write like this. Okay, so it is at least 0. This means that we have an intersection point here. So now what we need is we need to write the range of the angles. Yes, so the range of the angles is from AD to BD. Let's try and write it. We have revolving integral. What is revolving integral? Let's return to the previous part. And here we have actually everything that we need. So we need to calculate some integral from L to R. Yeah, so let's write the function. Also the length of the vector. And what? And also a lot of angles. Alpha, beta, and delta. Okay, to do that, let's just return v times ups of substitute r minus substitute l. Let's write a function substitute. Let's call it gamma, actually. And here we need to... Actually, I can put it here. So we have three addends. Sine gamma minus delta. times cosine beta minus alpha plus sine gamma minus alpha plus beta minus delta and sine 3 gamma minus alpha plus beta plus gamma. Okay. Great. We have found the revolving integral. Now we only need to substitute the right numbers here, because there are a lot of numbers. Let's start. Okay, first of all, actually, let's also denote all the points. I like it more. It is done the same way. So PDDA equals GA, B equals GB, C equals HA, B equals HT, HB. So we have an intersection point here. This indicates so that we have an integral from AD to BD. From AD is tan 2. So let's call something. Let's call so we have here BD, AC. So a tan 2 of, let's write a function actually. Plot tan 2 of PDTA. And it takes a.y, a.x. So we take arctangent of AD to BD. No. Or yes. Yes, actually. Yes, that's it what we need. Okay, then we need V. V is the length of the vector AD. And then we need alpha, beta, and delta. Alpha is actually a tan 2 of AB, I think. So actually they are fixed. So alpha is always a tan PDD of AB. Beta is always a tan PDD of CD. And gamma actually changes from time to time. Delta. In this case, for example, delta is a tan PDT of AD. Excellent. Here, what is int 2? Int 2 is from atan PDD BD to atan PDD AC. However, sometimes AC is not something very good. It usually happens when one of these points is an intersection point. So how do we avoid that? How do we avoid that? For example, we can simply check that this distance is not, the distance is not huge. Yeah, how do we check that the distance is not huge? Okay, so if len between A and B is less than 1e minus 10, between A and C, and dist actually, then we need to come up with something else. Actually, we don't need to come up with anything, we just do it. Yeah, and finally, we have some integral between this direction, AC, okay, I understand. So let's do like this. Let's say let me think. Okay, I want to take AC. Okay, so delta AC equals, so if this is greater than 1e minus 10, then this, else, for example, 0, doesn't matter. So, for example, we can say that if common, then delta AC is same as BD. I think BD, yeah. And then we say that floor in 2 is this. And finally, in int 3, we integrate from delta AC to BC. And here BC, and here BC. Otherwise, it's actually almost the same, but we need to be ready that the intersection is somewhere in the sky. Let's draw it. So we have 4 angles. From CB to AD, nothing. Then from AD to AC. Actually, let's in this case, let's go clockwise. So from AD to BC, nothing. To CB, nothing. Do I have CB actually? I have CB. No? CB? Yeah, in the beginning I have CB. Ah, CB is empty, okay. I understand. So from AD to CB I am empty. Then from CB... Okay, let's draw it like this. From GA to BC it's empty. Then from BC to... From BC to BD. From BC to BD we have BC. Then from BD to AC. Actually, yeah, we can draw like this, always. Then we have an integral from BD to delta AC, which is quite straightforward, but here we have CD. And finally, from delta AC, we have the rotation to AD. And that's it. In principle, we can say that what ans equals this. And everything broke. Ah, int. It should be int. Okay, I have written everything, so the solution is ready. And I can almost say that it is correct, but I am not sure about that. Especially this one. This can't be true. So this is the answer to some samples. And this is actually correct. Yeah, this is correct, but this is the parallel case, so it's stupid. It's correct because it had no choice but to be correct. And the only thing that we could test is wrong. Okay, we can look at what it says. It says that 1.5. And actually, for when everything is doubled, for some reason, it's halved. Well, it's strange. Actually, it's really strange. It's really strange. Ah, maybe I need to multiply it by v cubed. Yeah, maybe I need to multiply it by v cubed. At least now it doubles when I double everything. So it seems like we need to investigate into this thing. Okay, so let's look. 0, 0, 0, 0. What did it say on all zeros? 0. Actually, when both zeros, it should be 0. And now it should be non-zero. 0, 1, 0, 1. Yes, it should be non-zero. So we have AB like this and CD like this. Ah, common is like this, And if yeah, maybe this was wrong. Okay, it's a bit better, but still incorrect. Ah, bad. Okay, we have several integrals. First of all, from 0 to 1. Ah, I forgot the most important thing, actually, when I was taking this integral. I forgot the most important thing, and that's why it's incorrect. So instead of v cubed, I actually needed to take v squared. But I also needed to multiply by the distance. Yeah, I also have the distance. Okay, so let's think. We have two lines. We simply have two lines. Okay. And we have some vector which actually looks like this usually. But okay, let's draw it like this. And we always take two lines which are perpendicular to the direction. So we have the direction phi. So we have v here, but instead of v here, we'll need to integrate from the left quarter to the right quarter. Okay, so let's think. So we have two lines. We have a vector. We have some chosen direction. We have some chosen direction. And we integrate from 0 to v something. So first of all, we take our point x and we add okay, let's call this point s, and we add xv. So we have a point. Then we need to draw this line. And we need to find these 2 points. How do we find, for example, this point, T? If we know that this point is, I don't know, K. We know that TK is perpendicular to N. And also we know that if we take this direction, which is gamma prime, then and this point C, then CT is perpendicular to gamma prime. And this can be called, so actually we can say that T is simply C plus like Z CD. Let's multiply it by N. So we know that CT is ZCD. Let's rewrite it as CK plus KT is ZCD. And let's multiply it by N. When multiply it by N, we destroy KT, and we know that NCK equals Z NCD. From this we can get that Z is NCD minus CK. No, we cannot. You can say that Z is NCK over NCD. Okay, actually, sorry, but I'm again so tired that I'll have to stop now and continue maybe some other day. Thank you for watching.